So welcome to this session about reactive frontends with RxJS and Angular. I know this is the last one of the day, and I guess that you are all tired, especially with all the content that we have here in the conference. Hopefully, you're enjoying it. So my name is Sergi Almar. I'm actually a backender more than a frontender, but I guess like more of you guys, well, you are backenders, but at the end of the day, they have to jump into the front end. So I'm actually a Spring certified instructor as well, so I'm delivering some of the Spring trainings, and I run the Spring I/O conference in Barcelona. Anyone heard about Spring I/O, Barcelona? Some of you? Happy days. All right, so I guess that you have heard a lot about reactive support in the conference. So I guess that in every single time slot, you had a reactive talk, right? And it's actually amazing the efforts towards Spring 5 and Spring Boot 2, leveraging Project Reactor, but not only on the core, but also on all the projects in the portfolio. But then we jump into the web layer. And what do we have? Well, to introduce RxJS to bring the reactive programming model into the web layer, and then we're going to integrate that into Angular. This is not an Angular talk, right? So this is more about using observables and basically integrate those into Angular, because Angular leverages RxJS, so we need to know about RxJS if we want to use Angular. So I'll try to cover this in half an hour, and I'm going to have half an hour extra to do my demo, right? So we'll try to basically cover all the theory in half an hour. We'll take all the pieces and then put them together into a demo, so we basically, or everything clicks, hopefully, at the end of the presentation. So ReactiveX, so reactive extensions, right? So just quoting the website, it's an API for asynchronous programming with observable streams. And I would like to emphasize on two concepts here, asynchronous and streams. We're going to talk about streams, basically events that will flow, right? And we'll be processing those events asynchronously. And the reactive extensions actually comes into different flavors, right? So we have support for a lot of languages, and I guess that you may have heard about RxJava, which is basically the reactive extensions for the JVM, which also Spring supports in the backend, right? So at the end of the day, RxJava also implements the reactive stream spec. So it's a publisher, so it can be integrated with your Spring MVC, right? Spring applications as well. But today we're going to focus on RxJS, which is the JavaScript flavor of the reactive extensions. I'm going to use TypeScript in the slides just because we'll be using Angular afterwards. So if we take a look at our web apps, we have a lot of events, right? So these could be DOM events like mouse clicks or mouse moves, or maybe something that we type into a text input. We could also have like AJAX requests. Those are also asynchronous requests. We could have WebSockets, right? So basically sending streams of data. This might be like a stream by itself, right? So it's basically a lot of values that are coming into a long-living connection. The same applies to server-side events, a little bit different, right? But the same concept, just streaming data from the server side to the client side. And animations could also be a form of like a stream, right, of data that we can process. So we've actually manage, right, asynchronous processing in JavaScript for a long time, right? So we had the callbacks, right, which were maybe not the best thing to use. So we ended up having the callback hell. Then we introduced promises. If you use Angular 1, for instance, promises were part of the framework. But well, we have some problems with promises. How do you wrap, for instance, a WebSocket into a promise? How do you retry a promise? And how do you cancel a promise? Right? So it's not or maybe there are better ways to do those. So introducing reactive programming, well, we're going to see the benefits, right, in hopefully in the next slide. But you'll end up having clean code, right, really understandable, right, with, well, actually less code than with the imperative approach, because now we're going to move from imperative to a more declarative approach. RxJS is all about declarative, right? So we're not going to think about imperative code like if that happens, do this, and if that, do that, right? So everything will be declaratively and really concise, right? So we're focused on the result, not on the algorithm on how to do things. So we know that we want to do that, but we're not going to specify actually the algorithm to do that. So we have a lot of complex operators that will help us maintain that like really simple, right? And doing a lot of work. And observables can be canceled. That means that, well, if you have an HTTP request, for instance, and you're not interested in that request, you can cancel the observable, and the HTTP request will be canceled as well. So we can cancel what's ongoing. But there's no such free lunch, right, as always. So reactive programming and actually going for this approach will be more difficult to debug, right? So we also have a learning curve. We have to switch from imperative to declarative. So there's a cost, actually, on that. But it pays off. So let's start with the observables. Let's start by creating the observables. So RxJS offers you some factory methods that you can create an observable of like a static data source. It could be like numbers, strings, anything you want, static. We could create an observable from maybe an array. We could create an observable from events. Those could be like mouse clicks, right? Or it could be like messages coming from a WebSocket. We have other factory methods that allow you to create an observable for, well, a specific interval. So we can actually emit values on a specific amount of time. So we have a lot of factory methods, right? So this is basically our producer, the guy that will produce events, right? But these observables are lazy, so nothing happens if you just declare them. So you need to subscribe to them, right? So provide what's called an observer. If you have a more complex scenario where the factory methods are not enough, you might create your own observable. You might define how the observable emits values. Right? So here we have a really simple example on how an observable basically sends or emits 4 values, welcome to Spring Web Platform, and then completes the observable. Right? So that's quite, well, a really simple example, but this shows that you can actually create and wrap any data source on an observable. The good thing about observables or RxJS is that we can define any type of data source. Could be a static, could be dynamic, could be anything. And we can treat the values coming from that data source in the same way. Right? So we are abstracted from the data sources. So it's like when you go on YouTube, right, and you have a channel. That's my channel, right, the Spring I/O conference. So you have to subscribe to that channel, right? So in order to get notifications on new videos published. So when you subscribe, then if I publish a video, you'll get the notification. But if you don't subscribe, you won't get anything, right? So we need to provide an observer. We need to define who's going to receive, right, those messages emitted by the observable. An observer is nothing more than this interface that has 3 callbacks. The next callback, which will process the next or the immediate value, the error callback, which will process any errors, and the complete callback, which will process the complete notifications when there are no more values to be emitted by the observable. So this could be an example of an observer. Right? So we have an observer implementing the 3 callbacks, right? So next, error, complete. But this observer can also be partial. You don't have to implement all the 3 callbacks. It could be only the next, right? So that's usually what we want, what we do, right? So we just implement 1 callback, and maybe that's enough. So we're going to separate who is the producer, right? So that's basically what we have seen with the factory methods. Right? So we create an observable. So this is lazy. Nothing happens when we create the observable. But this is the guy that will produce the values. So this will produce a value. This will emit a value every second. So we need to subscribe to it. And this will be the consumer. This is the one that will consume that value. So this is a partial observer. So it only implements the next callback. So it will only have one callback implemented. But in between the producer and the consumer, we can have a pipeline of operators. And that's basically the value of RxJS. Right? So how we basically deal with the values that come from the producer into the consumer. So this is basically what really gives, right, the power to RxJS. So when you subscribe into an observable, usually we create resources. Like when you subscribe to a mouse move, right? So in this example, we are creating an observable from the mouse move event, and we are subscribing to it. When you do that, at the end of the day, you're creating an event listener. And you need to release those event listeners when you don't need them. Right? So maybe if you have an Angular component and you don't need that component anymore, you need to release those resources. So you need to unsubscribe. Right? So that's important to not have memory leaks. Right? So when you subscribe, what will be given to you is a subscription that you can use to unsubscribe at any point. Right? And this is important because you're going to release the used resources, and also you're going to tell the observer that, well, we won't have any more messages. So regarding operators, right? So we have plenty of them, right? So we have operators to create streams, to transform those streams, or filter, or combine, conditional operators, error handling operators. You don't have to learn them all, right? So I guess that you are more than familiar with the traditional ones like map, filter, if you use Java streams, right? So they are basically the same here, right? And I would start with the most simple ones, with the ones that you know. And when you need more, well, you basically learn them, right? So you cannot learn them all. We have plenty of them, right? And maybe you don't have the use case to use all of them. So the operators allow you to use dot notation to basically chain these operators into the pipeline. But in RxJS 5.5, the lettable operators were introduced. And a lettable operator is nothing more than a function that takes an observable and returns an observable. That means that every time that you go through one of these operators, it takes an observable, it basically subscribes to this observable, and returns another observable downstream. So using the lettable operators allow you to just import or pull in the operators that you need in your application. So you can reduce the bundle size of your application. Otherwise, you'll be pulling in the whole library. So that might be the preferred way to use the operators. So now we're going to use the pipe operator that will define the pipeline. We're going to use the different, or combine the different operators, and we're going to go through all these operators. That's a really simple example. Interval, so emitting a value every second. So we filter that, right? So we then map it and take just 5 numbers, so we don't have like an infinite stream and subscribe to it. So said, you don't need to learn them all. Right? So when you need or you have a requirement and you don't know which operator to use, you can go to the RxJS website, and if you scroll down, you can answer some questions, and it will tell you which operator you need. Right? So do you have an observable? Yes. Well, do you want to transform the data? Yes. Right? So actually, you answer some questions, and then it will tell you which one you need. Another good resource could be RxMarvels, which graph, right? Every single operator, so you can see how it behaves. It's a really good resource. Another resource could be learn.rxjs.io. It's a really good website that also will give you examples on every single operator, so you have more or less in mind, right, what they are doing. So don't worry too much, right, if you don't know all of them. It's overwhelming, right, when you start, because there are so many of them, and some of them look quite the same, but they are slightly different. So you'll be basically learning them, right, as you're using RxJS. And I think that one of the best things with RxJS is to compose different observables. right? So let's imagine that we have these two different observables. I have an observable of like 3 different strings, so that's going to emit these 3 different strings, and yet another observable which also emits 3 different strings. The merge operator is the easiest way to combine different streams. So we can use the observable.merge to combine different streams. And now the resulting stream or observable will be the combination of the 2 streams. So that would be like having an OR applied to both observables. But notice how this simplifies the subscription model. So instead of having to subscribe to 2 different observables, we can now merge them and subscribe to a single one. So this simplifies the subscription. So you should have as many, or actually as less subscription as possible because, well, you don't want to manage a lot of subscriptions. So this, at the end of the day, will do something like this, right? So let's imagine that the first value is emitted from the first observable. So as we are merging both observables, when we subscribe to the resulting observable, we're going to get Spring. Then the second one will be Spring Boot. If the cloud stream emits a value, we'll get it as well, and so on. Right? So we're going to get all the values emitted by any of these 2 streams. So we're going to receive them as they are emitted by any of these 2 streams. We're not going to preserve the original ordering of the strings. So what's merging? So let's talk about switch map, which is a really important operator, I would say. Right? And we're going to talk about that later on. So switch map lets you subscribe into the projected observable. So here we have an observable of 1, 2, 3. And we are using switch map to change to another observable of the same number and another number, which is the number multiplied by itself. So when we subscribe to this observable, what will happen is that, well, the first observable will emit 1. We're going to go through the switch map. And at this point, we're going to switch the observable where we are subscribed to. So that will issue 1 and 1. Right? So 1 is the value. And then 1 multiplied by 1 is 1. 2 will just emit 2 and 4. And then 3 will just emit 3 and 9. So that's basically what we're going to get into the subscription. We're going to see some examples of that, and we're going to see why switch map is so important. Fork join. This will allow us to basically run different observables, different streams in parallel. So let's imagine that I have to do like 3 different requests, HTTP requests, and I don't want to wait for the first one to finish to start the second one. I want to issue them right, in parallel. I can use fork join. So we can use observable.forkjoin, define the different observables we have, and what this will do is to basically take the observables, fork them, run them in parallel, and it's going to wait until all of them have finished. So maybe the first one finishes first, but then maybe the third one finishes afterwards, and we're going to wait until everyone has done. Right? So at this point, maybe we're going to, I don't know, we're going to show like a loading progress, and at this point, when everything is done, we're just going to hide it. So what we'll get is nothing more than an array of the results of every single observable. So the first result will be in the first position, second, and third. So we've been in the happy case scenario always, but we don't live in a perfect world, right? So these observables might throw exceptions, right? So you might want to deal with those exceptions. So in this example, what we see is that we create an observable of a range of, well, 20 numbers. So we're going to start with 1, and then we're going to meet 20 numbers. But if we meet number 13, the observable will throw, or will map it to an error. Right? So this error will just go downstream, will be propagated downstream. And when we have an error, the stream will just finish. We're not going to get 14, 15, 16. It's done. We got an error. And if you remember the observer that we have seen, we had a callback, which is the error callback, which you can pass, you can implement. So what we can do is to implement the error callback. So when we subscribe, we have the next callback plus the error callback. So when the error is thrown, the error callback will be executed. But again, the observable will be over. So it will be marked as closed. So we won't have any other value emitted. So we're going to start with 1. We're going to continue 2, 3, 4, 5, 6, 7, until 13. That will throw in an error. And this will just close or cancel the observable. So how can we prevent that? We have the catchError operator. So usually we use the catchError operator close to where we are supposed to have the error. So now we can catch the error and just map it into an observable. So instead of throwing an exception, we can return an observable. So in this example here, well, we have the same example, but we have added the catchError. So now when we get an error, we're going to switch to another observable, which has this range factory method. We're going to start with 100, and we're going to emit 3 values. So the output will be, we're going to get from 1 to 12. When 13 is emitted, we're going to get an error. And we're going to switch to the other observable. And that means that, well, we're going to start with 100, 101, and 102. That should be 101 and 102. All right. So what's a little bit about RxJS, right? It just happens that Angular leverages RxJS. And if you take a look at the API, you'll see a lot of observables, right? So it could be maybe in the HttpClient. That might be the most obvious example. So everyone needs to do HTTP requests to the backend. So we will be using the HttpClient, and these will return observables. The Reactive Forms also, right, have observables. The router has observables as well. How we do component communication, right, might be an observable or a subject or an event emitter, which is based on a subject, which is also an observable. So how many of you use Angular 2, 4, 5, right? Call it, OK. Right. So Angular lets you break down your application into modular pieces, which are called components, right? So when you have a component, well, you can have callbacks on, or actually, initialization callbacks and destruction callbacks on those components. So we can implement the onInit and onDestroy callbacks. So onInit is a good place to create observables, or actually subscribe to the observables. So in this example, what we see is that we define an observable, which is basically tracking the mouse move, right? So we, every time we move our mouse, that will emit a value. And we just map it into X and Y positions. We're also subscribing to this observable, right? So we are going to take this XY position and store it into one of the fields in the component called mouse position. And notice how we're getting back a subscription. Remember that when you create or subscribe to an observable, you are creating resources. This is creating an event listener. And we need to destroy that event listener to avoid memory leaks. So it's your responsibility to unsubscribe from this observable. And a good place to do it is in the destruction callback, which is the onDestroy. So we take this subscription and we unsubscribe it. But what if I have, like, I don't know, 10 observables? Do I need to manage all the subscriptions myself? For sure, you'll forget to unsubscribe from some of them, right? So as long as you can, don't manage subscriptions. So Angular has an async pipe that allows you to avoid subscription management. So now, in this example, what we do is to get a reference of the observable. So we create an observable from the event mouse move, and we are getting the observable reference. So we'll be using that. By the way, the $sign is basically the naming convention for observables. So when we have a $sign, that means that this is an observable. And we're going to use this observable in our template. So notice how I'm referencing the mouse position in the template, and I'm using the async pipe. So this will subscribe to the observable, and it will unsubscribe from the observable when the component is done. So notice how we are not doing any subscription management, much better than the previous approach. Another place where you'll have the observables is the HttpClient. So HttpClient is really simple, well, a really convenient component, which has one-liner methods to get, post, put, delete requests. It also supports typing the response. So we'll be using TypeScript, so we can basically define what type are we getting back from a GET request, for instance. And it also supports adding interceptors. So we take a look at any of these methods here. Let's take a look at the get method. You'll see that in the signature, this will return an observable. So that means that when you do a get request, you can subscribe to it. So we'll be doing something like this, HttpClient. You can define the type that you're getting back. We're going to get a user. We're going to define the URL. And then we're going to subscribe it. So this will do the HTTP request. And when this is done, we're going to have the callback executed. RxJS has also a retry method, which basically allows you to retry a failed stream. So instead of just throwing an error, you can retry. So, and this is specifically useful for the HTTP client, because maybe you're on your mobile, you're going through a tunnel, or you don't have like network for a period of time, and you may want to retry the operation before failing. So you can use retry and define how many times you want to retry. So that will basically do the initial request and then retry 3 more times. So at the end of the day, we can have 4 requests. Or if you want to be more flexible, you can do retry when, and this will allow you to specify how you want this retry to happen. So in this example, we see how we delay the retry 1 second, and then we retry 3 times. Right? So this allows you to have a more flexible retry. For the reactive forms, right? So we have different ways to deal with forms in Angular. We have what's called the template-driven forms, which is more or less what we have in Angular 1. And then we have the reactive forms, which basically introduce the reactive programming model right into the forms. And one of the things that allows us is to subscribe to changes on form controls that we have in our form. So for instance, if we have an input, a text input, and we want to get the values from that text input, well, we can basically define the form control, and this will give us this value change observable. So every time that there's a change right in the input, we can get, or we can subscribe to it and get the values. Or we can also get the status changes. Right? So if we have some validation, we can basically get when that form control is valid or invalid. Right? So we see also observables in form processing. So service-end events and WebSockets. How many of you use service-end events here? WebSockets? All right. Anyone used the reactive support for WebSockets, Spring 5? Not yet. Some of you? All right. So we've seen right, the way to create an observable. So we can actually wrap any data source right, with this approach. So what we see here is basically how we wrap an event source, which is nothing more than a service-end event, right, and into an observable. So what we do is to add an event listener, and when we get something from the event source, we are calling next into the observer. And the same applies to WebSockets. Right? So with the same approach, we can wrap a WebSocket object, we can start a WebSocket connection, and every time we get something on that WebSocket connection, we can just call next on the observer. Right? So pretty straightforward, right? But we see that we can wrap any kind of data source and deal with the messages right, independently of the source or in the same way. But now we have a problem. When we subscribe into the WebSocket observable, what will happen is that we'll establish a connection. But if there's another subscriber, it will also establish a WebSocket connection because it will reproduce the observable. And if there's another subscriber, it will also have a WebSocket connection. Right? And this is not ideal. Right? So maybe you just want one WebSocket connection to be shared across all the subscribers. So we have a new operator called share. Right? So now when we subscribe to or all the subscribers that subscribe to this observable will share the same subscription. And this will be basically completed or canceled when all of the subscribers go away. right? So really useful for WebSockets and also for server-side events. All right, so that was like a really quick introduction to RxJS, right, and the Angular support. So what I would like to do now is to take everything that we have seen and put it into a demo, right? So we're going to see or put the pieces together. So my whole point of this example is to be able to just type here whatever name and basically look on GitHub for the profile and look also for the repositories of that user. That's my whole intention for the demo. So you have an Angular app, right? So we have, well, basically a main component. We have two child components, which are these two guys, right? So one is this one here, which is the detail of the user, and we have another component here, which is the repositories, right? So I'm going to focus on the main component, and so far I have this onInit method, which will initialize the form. So the form is nothing more than what we have here, right? So this really simple form. And then basically populating the user and the repos. And to do that, I'm relying on a service called GitHub service. Let's just do it like this. And this GitHub service currently doesn't have much, right? So it has basically a static array, and I'm just using, well, filtering on that array, right, to return a user. So let's turn that into a real app that connects to GitHub, gets the user, and we'll start basically playing around with the observables. So the first thing is that what I do is to basically inject the HttpClient, so we can issue request, HttpClient, all right? So we're going to inject that in the constructor. And now I'm going to use the HttpClient to the get request, that will return a user, because, well, I have that in a class. So that's basically my user definition. And I'm going to do a request, and here's my base URL. So I'm going to use the base URL, this.base URL, and I have here slash, and I'm going to pass the username passed in the constructor. Sorry, in the method. All right, so now this, as we have seen, returns an observable. So I'm going to change the return type to observable, and that's going to be an observable of a user. If we go back to our main component, where we had this call, so now we cannot assign an observable to a user, but what we can do is to subscribe to this observable. Right, so I'm going to subscribe to this observable, and basically do this, that user equals user. So let's see if that did anything. Yeah, it did, of course. Well, let's complete that, and then let's go back to what we to our demo. So let's complete that and basically change this second method here. I'm going to use also the HttpClient to get the repos. There's a missing. Here we go. To get the repos for a specific user. So I'm going to return an array of repos, and the URL will be actually the same one as this one, plus a slash repo. Slash repos. All right, so we have our service ready. So now we are returning observables using the HttpClient, and we are ready to basically go back to our component and subscribe also to the repositories. So we're going to change that. We're going to subscribe to this. That's going to be repos equals this.repos equals repos. All right. Great. So, well, we see that this worked. Actually, let me pull the developer console in. So let's refresh that and see that we got something in the network. So we see here a couple of requests, right? So this one and this one. So this one just connected to GitHub, and this one connected to also GitHub to get the repos. I have an interceptor that's the client secret and API. I shouldn't do that in here, but well, just for the purpose of the demo, I'm going to do that in here. But I see that, well, I got some response here, right, on the data from GitHub. All right, great. So I see that I get a lot of repos, and I just want to list the popular repos maybe. Right, so maybe I can filter the repos I get from the service. Right, so I can just use the pipe operator to do a pipe, and I'm going to map the repos that I get, so I know that this is going to be an array of repos. And as this is an array, I can use the filter method on repos, the filter method to filter every single repo on that array, and I'm going to basically check that the stars that the repo has are more than 50. Right? So I don't want to get all of them, so I just want to get the more popular ones. So if we go back, so I see that, well, this has been reduced, and I just have one, which is the one that has more than 50 stars, right? Which is pretty nice, right? So it's basically, well, really declarative here, so I'm not doing any imperative approach. All right, but this is kind of a static still, right? So I'm just passing in the username here, but what I want to do is to be able to type something here, right, and basically load that user. How can we do that? So we can use the reactive forms. So as we see here, when I initialize the form, I just create something called search field, which is a form control, and I create a form which is basically created by this form builder, and we define something called search field. So I'm going to get this search field. And well, let's do directly this dot search field dot value change. This is search field dot value. Where are you? Value changes. Here you go. That's the observable that will give me all the values. And just to see that this works, I'm going to subscribe, and I'm going to just log it into the console. So let's go back. Let's just put the console here, and let's type something here. Well, it seems that it works. So we got the values coming in, right? So, but now I want to connect these into the GitHub search, right? So how can we do that? Well, we know that we can do switch map. So when we get values from the text input, I can switch map the observable and do an HTTP search. So let's do that. Right? So let's basically get rid of this subscription here. And what I'm going to do is to define a constant for that observable. So I'm going to define a constant for this observable. I'm going to call it user search. I'm going to use the $sign to say this is an observable. And I'm going to basically pass it a username. And I'm going to get rid of this guy here. And I'm going to do the same thing with this second subscription. Right, so I'm going to get rid of the subscription. I'm going to basically assign this repo search into this field. I'm going to pass the username like this, happy days. And I'm going to do the same thing with this observable here. So just defining who is the producer, who is the data source, we can see a clear separation or a clear, or we can compose those better. And this will allow us to basically have a better picture on who is the producer, right? You don't need to use an observable off, right? So basically, this is Lambda, so we're passing a username, and this is returning the observable to us, right? So this will return an observable already. So I'm going to create yet another observable, which will be search field observable, pretty straightforward. So I'm going to start with the search field, right? So that's going to be my source. So that's basically where I type, where I get the values from. And I'm going to basically pipe it. And what I want to do is to switch map, right, to the user search. So when I get a value, I'm going to just do a user search, and I'm going to subscribe to that. I'm going to say user, because that's returning a user. This.user equals user. Right? So pretty straightforward. So we see it clear. So that's my source, data source. I switch map to user search, and I subscribe to it. Let's see if that works. I'm not sure. Right? So let's check that. All right, so S, I have some guy here which I don't know. E or A, L, M, A, R. Here you go. Here I am. All right, so you see in the network that, well, we have plenty of requests. All right, so the first one was this one here, S, A, L, M, A, R. Right, so we see a lot of them. So that works, right? Perfect. All right, but let's continue. Let's like search for this guy here, which doesn't exist, of course. So we see that there's an error, right? Of course, that basically returns a 404. And we know that when there's an error, the observable is canceled. So now what happens is that if I type something here, we see that it's not working. The observable is canceled. So we haven't like handled the exception, and the observable basically died. All right, so just to make sure that it died, right? So what I can do is to implement the error callback, right? So I can say, well, when there's an error, could you please tell me that there's an error? Console.log, tell me something meaningful, boom, right? Or maybe with more O's than M's. All right, so let's see that this is actually an error, or we got an error. Let's type something here like this. So we see the boom here. So that means that the exception reached the callback, and the observable was canceled. So how can we solve that? Because we want to have that search working all the time, right? So maybe we can use the catchError operator that we have mentioned. And when there's an error, maybe I can return an observable of an empty user, maybe, right? Would that work? Well, I don't know. So let's try that. Oops. Here we go. Let's try that. So I'm going to try to search for something which doesn't exist, hopefully. And well, what we see is that, well, we got this empty because we returned an empty user, and we didn't get the boom message here in the console. That means that the error callback was not executed, but we actually switched to another observable, which was an empty user. And that means that we canceled the initial one. So if I come back here and I try to do something like, well, searching for a specific user, well, it's not working. All right, so maybe we can take this guy, right, the catchError here, and just put it in the inner observable. So I'm going to try to define it here. I'm going to pipe it, going to define it here. So when there's a search, if that fails, we're going to catch it and return a new user. So hopefully, if I do that, well, maybe I'm not going to fail. So let's see if that works. Let's type something like this. You see, boom here. There's an exception. Nothing working. Where am I? Where am I? Where am I? Oh, yeah. Here you go. Is it like pipe? Here you go. Thank you. So you're still with me. I like that. All right. Let's refresh. Sometimes it helps. Nothing happens. Here we go. It was slow, just slow. Right? Okay. So, well, from the network, we see that we get a lot of requests. That's also interesting. Right? See the status cancel here. When I type really fast, what I'm doing is to emitting a lot of values. And of course, the HTTP request didn't have time to finish. So when I type yet another value, what it will do is to cancel the previous observable. And when I cancel the previous observable, the HTTP request gets canceled as well. I'm not interested in that. I don't want to have race conditions where I issue a request, I issue another request, and maybe the second one finishes before the first one, and then we get like values which are stale. Right? So I'm going to cancel the request. But that's also really interesting. All right, so we got a 404, but hopefully now that's working. But it's maybe it's slow because the Wi-Fi is kind of, yeah, here you go. It just happens that those network requests are down here. Yeah, here we go. So now our search is working even if we got an error, right? So I can try to get an error. So that's returning an empty user, but I can actually start typing again, and I'm getting the value, right? So we handled the errors, and maybe we can also do that for, not here, but maybe for the repo search. So instead of returning a new user, I'm going to return an empty collection. All right, so now I switch map to the user search, but what about the repos? I want to do the repos as well, right? So maybe we can do that in parallel. Maybe I can search for the user, I can search for the repo. Maybe like fork join can help us here. So let's create another observable. So I'm going to create another observable called user and repo search. All right, that's an observable. I'm going to use the fork join operator. Let me just put that here. I'm going to pass that username as well. And I'm going to fork join the user search, passing in the username, and the repo search as well, passing in the username. So we have yet another observable. So that's now an observable that I can use to switch map to. So instead of switching map to a user, I'm going to use or switch map to user and repo. So hopefully that works. And when I look for someone like Spring projects, here you go. Let's give it some time. Maybe refresh. Spring projects. Oops. It actually issued. Oh, so something is wrong. What is that? When I have the fork join, remember that the return is an array of the results of every single thing that we have forked. So in our subscribe, we say that we get a user, but that's not true anymore. We have to change that, right? And this is not true. And now I'm getting two things. So first thing is the user, which I'm going to get in the first position. The second one is the repos, which I'm going to get in the first position. So now, equals. So now, hopefully, we did it well. And when I'm looking for Spring projects, what do we have? Here you go. Right? So that's Spring projects, and we have some of the most popular repos in here. Have a question back there?
So is the positioning based on how you pass them to the
Yes. Right? So I define like user search and repo search, and we're going to get like the results in the same position. Right? So they run in parallel, but we're going to wait for all of them to finish. All right, so that worked. Right? I'm pretty happy about that. All right, so notice how readable that is. Search field, pipe, switch map, user and repo search. Isn't that readable? Easy, right? So the important thing here is to basically separate. This is my source. This is another source, right? And we basically compose these observables, right, with the operators, and that will give you a lot of power. All right. Now I'm going to, or I want to, I'm a fan of, I'm a fan of WebSockets, so let's play with WebSockets, okay? So I'm going to make up like a requirement, which is I feel lazy now. Right? I don't want to type here to look for, to search for users. Right? So I don't want to type here. What I want to do is to basically connect to WebSocket, and that WebSocket just give me whatever user. Right? And I'm going to display the user that the WebSocket actually sent me. So let's actually create an observable out of a WebSocket. So I'm going to create an observable of something. And I'm going to return an observable, which I'm going to create an describer. Let's wrap a WebSocket here. So I'm going to define a WebSocket const WebSocket new WebSocket. And I'm going to just use WS localhost /search WS. So that's my WebSocket definition. And I'm going to define that every time that I get a message, I'm going to define an event listener. So every time I get a message, I want to pass that message to the next of the subscriber. So I'm going to use subscriber.next. I'm going to pass the message itself. All right, so this is how we wrap a WebSocket. Right? So easy. So I'm going to just define yet another observable. So that's going to be const WebSocket observable, and I'm going to create it like this. And I'm going to use an operator called tap. It's called do or tap, and this allows you to do anything you want. And I'm going to basically output the messages that I get to the console.log, just to see what I get from the WebSocket. All right, so that will be my source, but I need to create our WebSocket. So I'm going to go to my backend application. We have two applications, the Angular application, and now this is the backend application. I'm using Webflux, right, to create a WebSocket. So we're enabled cores because we're in different domains, right? So I have this WebSocket handler, a WebSocket mapping, and I have a Flux, which will be my producer on the service side. So this Flux is really simple. So it's basically having like these three strings: Spring project, Almar, JOSLang, and I define that I want to delay that with 5 seconds, and I want to repeat. That will be constantly emitting these three values, right? And it's going to separate it with 5 seconds. So I'm going to create a bean. And that's going to be a WebSocket handler. WebSocket handler, WebSocket handler. And a WebSocket handler basically sends or allows me to send messages based on a producer. So my producer will be a Flux, of course, right? And I have to produce WebSocket messages, right? WebSocket messages. And I'm going to use the Flux that we've seen here, search Flux, and I'm going to map it to a WebSocket message because this is a string. I have to map it to a WebSocket message. So I'm going to map it to a WebSocket message, text message. So that's going to be my producer. That's going to be my producer. So given my producer, I can say I can return a WebSocket session.send or publisher, call it however you want. And that's going to be my guy. So I'm going to take this WebSocket handler, and I'm just going to map it here. I have that done already. And I have a URL mapped, so search WS to that handler. So hopefully, if I run that, this will start emitting values when I connect through WebSocket connection. All right, so we are here. Just let me add a statement here, WebSocket created, yes. All right, so now we have this observable. So I'm going to change the search field observable by the WebSocket observable. So now, instead of typing, I just want to rely on this WebSocket connection. Give me the users. I'm going to just display them as they come. All right, so let's see if we get anything here. Localhost that's going to be 8080. Where are you? That's missing the port. All right. Here you go. So we see WebSocket created. Let's wait. Here you go. We get something, which is a message event. Right? So that's basically what I tapped into. Right? So that's basically done by this tap console. So I just created a WebSocket connection, and I subscribed to it. And every time I got a message, I just display that in the console. But we see that we don't get a simple string. Instead, we get this object message event. But if we take a closer look here, we have a property called data, which is what we are interested in. So what I can do is say, well, I'm not interested in the whole thing. Could you please give me just the data thing? Right? So I'm not interested in the whole object. So let's see what happens now. So WebSocket is created. Happy days. But now we see Spring projects coming in, and it's loading the whole thing, just waiting. So Sergi Almar coming in, waiting 5 seconds, just long, coming in. It's taking some time. Here we go. Right? It's great, right? So I don't do anything. I feel lazy. So WebSocket connection is actually sending me all the data. But I also want to search, right? Why it's not working? I also want to search that. How can we do that? I can create yet another source, right? And I can do, I don't know, text and WebSocket source, right? And I can basically use, can anyone help me here? Like merge, maybe? Yeah? I can merge two observables. Yeah, I can merge the search field plus the, let's put that down here, plus the WebSocket one. Is that what we want? Yes. Can we change that source so we are happy with the WebSocket and the text? All right, so here you go. So WebSocket's created. So hopefully I'm going to get some values here, but I wanted to type S here. Here you go. So I got this guy. I don't know who he is, but it was loaded. Here you go. So that works. Right? So we merged two streams. We didn't care where those values came from, but we actually switch map to the GitHub search, the repository search, and so on. And I want to basically know or the number of messages I get from the WebSocket connection. So I'm going to create another subscription, right, on that WebSocket connection. I'm going to subscribe, and I'm going, not subscribe, but I'm going to just pipe, and I'm going to use a scan. Scan is like a reduce, right? But it allows you to emit the partial values. So I'm going to have the accumulator and the value, and I'm going to say accumulator.value and emit that. And then I'm going to subscribe to it and console. Well, let's do it more verbose. Console.log. I got our number of messages. All right. So now I want to see in the console the number of messages I got through the WebSocket. So now we see SpringOne. Maybe I need to do something else. So before counting, I can just map every single message to 1. Right? So I just say, well, give me a message, map it to 1, and now I count it. Now it's working. Right? So hopefully that will work here. So I got Spring projects, number of messages 1. I have a tab as well, so that's why we have repetition as well. So number of messages 2. But there's something which is not right. So which is what we see here. WebSocket created twice. Right? So we see that just by subscribing twice, we got 2 WebSocket connections, and that's not what we want. Right? So that's completely wrong. So just because I want to count the messages, I don't want to just create a new WebSocket connection. So maybe I can come to the WebSocket thing. Here you go. And I can just share that. All right. Will you be happy with that? Here you go. So now we have just one WebSocket connection. We have multiple subscribers, but I just have one. And as you see now, Spring Projects is not output twice, but I'm just getting the values, updating these, and basically printing the number of messages we got from the WebSocket connection. Question?
Where's the state of the accumulator?
It's actually, I mean, where's the state of the accumulator stored? Those are pure functions, right? So you shouldn't have any side effect. So it's not like I have a field there and I update the field outside the observable. So everything remains inside the observable, right? And that's the beauty, right, of this. So everything is pure functions, right? No side effects. Everything inside, right, the same observable stream, and we don't move to the outside of the observable. Right? So everything is self-contained.
Is there a function that's emitting the current value?
Yes, yes. So reduce is basically reducing and just giving you the last value, and scan is giving you the partial values. Right? It's like reduce, but partially you're emitting the events. All right. Do you have 3 more minutes? Yes. All right.
Which one subscribe?
Oh, that's a good one. Yeah. We should have this unsubscribe, of course. Right? So for the WebSocket, right? Actually, when you use the HttpClient, just because it's a one-off, right? It's one value. So when this comes back to you, it's already unsubscribed for you. So you don't need to unsubscribe for an HTTP request. We should unsubscribe from a WebSocket connection. Right? The question was, where is my unsubscribe? Right? So from the WebSocket connection, we need to close the connection. But in order to be able to close the connection and be able to unsubscribe from the observable, what we'll have to do is to add a little bit more code into this creation of the observable. Because usually when we create the observable, we have to return how we unsubscribe from the observable. We have to return that, and we are not returning that here. We're missing some piece of code, right? Just because, well, this is a demo. But ideally, we should return a function which maps to unsubscribe, which closes the WebSocket connection, and then you unsubscribe in your code, right? But that's a good point. All right, so now, instead of a WebSocket, I'm going to create or wrap a server-send event, right? So not a WebSocket is basically, we have, let me just clarify that, because in the typings, just to tell TypeScript that we want to use an object called event source, I have here my type, and I have the definition of the type, so I can use it right in my code. But well, let's not get into detail because I'm just running out of time. And let's create an event source. That's not going to be a WebSocket. It's going to be HTTP, localhost, blah, blah, blah. And that's going to be a server-send event. So server-send event created. Who has used the server-send event support in Spring 5? Some of you? All right. OK, so in Spring 5, right? Get mapping. If I return a flux of strings, which is what we want, I don't know. I'm going to return my search flux. So this will basically return, right, or actually give me, right, a server-send event. So I can basically go to this mapping slash search server-send events. And this will start JavaScript and Java, same code. All right, so this will start a server-send event. So where are you? I'm missing some. What am I missing here? Maybe this. Yes, here we go. So now I'm going to create another observable const server-send event observable. All right, and I'm going to do the same thing. I'm going to pipe it and just plug into data because we can have the same problem. I'm not interested in the whole thing, but just in the data. So now instead of a WebSocket, I'm going to just define that my data source is a server send event. So hopefully that will work well. Let me just restart the server. Let's see if that works. Coheres, WebSocket. I don't want a WebSocket now. Just let me remove the subscription I had. Where do I have that? I'm lost. Oh, I just did it wrong. So that's the thing that I want to delete. And that's the, thank you. So you're paying a lot of attention. Awesome. So now we have this server send event created. Hopefully that will create that. Well, we'll see that values are coming in. But if I look at the network and I look at this request search SSE, I see the event stream. And I see that events are actually coming in, right, from the server send event, right? So that's not a WebSocket anymore. It's like a server send event, right? And I'm getting values from the server send event. All right, so I'm running out of time, right? So that's basically everything we had to do today. So I try to get everything that we saw in the presentation and put it in the demo. And I think that that worked pretty well. So, well, if you have any further question, real quick, or you can grab me, right, while grabbing a beer after the event. And just one more thing before you go, right? So I'm not sure if you're aware of Spring.io. That's the conference I run in Europe, right? So it's like the SpringOne for Europe running on in May 24th and 25th next year. So I hope to see you all in Barcelona, my town, right, next year. Thank you.